This is the Chapter 11, Part 2, Exam Review number 8. And this question is asking us to solve for k, which is just some integer that they have written in with the series that they've created here. So on this first one, I don't know which one's easiest to think about, but maybe we could just think geometrically for all of these first. So just as a reminder, in geometric, which all three of these are here at the ends, the second part of them, that the absolute value of the ratio has to be less than 1, not including 1. So that means in this first one, basically the integers we can pick are and there's a couple ways we could write it here, because we could also write it as from -5 to 5 non-inclusive, but I'm going to write it that we have to stick between -4 and 4 inclusive. And then on part B, then -1 to 1. And then on part C, -5 to 5. Okay, so we've taken care of the geometric part. So now on the first part, this has an n to the 1 on the bottom, which means it's harmonic, and the only way this is going to converge is if we have an alternating series. So we have to make sure whatever we pick for k, it would still alternate, which means if k is an even number, what would happen here is we would always have a negative to an even power, which would turn it to a positive. So we can't have any even numbers, so k not even. So let's see, let's make a list of what k could be then. So -4 doesn't work, but -3 would. And then -1. 0 is an even, so that doesn't count. So 1 and 3. Okay, so let's see on this next one, part B, it's an n squared in the denominator. And n squared, if we think as a p-series, it converges whether this thing alternates or not. So we don't have to put any restrictions on that part. So I think on letter B, we get to have -1, I should write k equals k. So -1, 0, or 1 would work. All right, and then on C, we're back to an n to the 1. So this is harmonic, it has to alternate. So again, we have to pick something here to make sure this kn plus 2 is not even. So the plus 2, if I do an even plus an even, I'll stay an even. If I do an odd plus an even, that'll be an odd, and that's kind of what we're going to be searching for here. And then we'll just verify that that makes sense, because this one's a little bit trickier, I think. So I can't have an even number, so I think -5, -3, -1, 1, 3, and 5 work. And let's just verify that that works with that sigma notation. So I'm just going to pick, let's say, a 3n plus 2. Let's verify that that actually does alternate. I think that's the big thing in my brain that I want to make sure. So when n is, it does start with a 1. So when n is 1, I would get a 5 here, so that would make it negative. If n is 2, I'm going to get a 6 plus 2 is 8, so that will make it a positive. So already it looks like it's alternating, so I feel confident with that answer.